All right, let's get started. Again, welcome to everyone who's joined us today. I'm Samantha Link, and I'll be moderating today's webinar on automated NDE tools for non-intrusive inspections. As we go through the presentation, all attendees will be muted, but please be sure to send in questions to the Q&A feature located at the bottom of your Zoom webinar screen, and we'll try and get those asked during the webinar itself. Just a little housekeeping as well, in case anyone gets booted or would like to share this recording with colleagues afterwards, we will be sending follow-up emails to you guys just to send the recording so you can watch it at a later time. I'd like to go ahead and introduce our presenter today, Quinn Holub. Quinn is the Global Business Development Manager at Gecko Robotics and has been in the NDT space for 4 years. Quinn has extensive technical knowledge and experience in robotic solutions for clients in industrial industries across the globe. You may have recognized Quinn from previous webinars with us on interactive inspection data exploration, and today he's going to take us through automated NDE tools. So let's all welcome Quinn.
Thank you very much, Sam, for the introduction there, and I really appreciate everyone taking the time to join us today. Hopefully this will be some good stuff for you, and we're going to go ahead and get started. All right, so risk-based inspection, or RBI, and non-intrusive inspections, or NII, are becoming increasingly common in the oil and gas industry. And there's a greater level of awareness and adoption in other areas, such as the chemical industry. Many engineers are justifying the use of these advanced integrity management practices with a number of advantages, not the least of which is cost. RBI and NII are designed to achieve significant cost savings and risk mitigation benefits across the entire equipment lifecycle. It's important to explore and consider the advances in the NDE technologies and their ability to satisfy the confidence requirements of these risk models. After talking to clients around the world about non-intrusive inspections, it's become clear that there's a lot of different levels of understanding about the considerations and the equipment that makes these kinds of programs possible. So today we're going to learn briefly about the codes and engineering considerations that go into non-intrusive inspection and understand why the latest automated inspection tools are so important for a quality outcome. Now, there's a variety of fixed equipment that's required to undergo periodic review and to quantify degradation and ensure safe and reliable operation. But historically, this has been achieved by internal and external visual inspection linked with surface NDE methods. However, as we all know, shutting down an in-service vessel, isolating it, and preparing it for entry can come at a high cost as compared to the price of the inspection. If we eliminate the need to enter the tank, we can eliminate the logistics of confined space entry and even a unit or plant shutdown. If we take this one step further, deploying automated methodologies to reduce or eliminate the time and cost of access logistics such as scaffolding can create even greater safety and financial value. A traditional time-based inspection practice implies that in-service and internal inspections are conducted at regular intervals. The financial loss component is not considered in many of the codes and regulatory standards which are concerned with safety. All the assets are treated equally, regardless of the damage mechanism and application, and this is an integrity management strategy gap for owner users. Traditional visual inspections of pressure equipment are conducted by qualified individuals to identify any visible integrity issues and to verify the equipment can be operated for another fixed term. This use of time-based inspection principles does not necessarily take into account the scope and timing advantages of a better inspection solution, better inspection tool set. So in practice, operators may choose the longest of these two intervals based on their situation. All right, so RBI processes, hopefully all of you have a little bit of exposure to RBI, but if not, here's a quick tutorial. RBI process results can predict when, where, and what to inspect at the equipment level. The extent of the area coverage, the percentage of the total surface within each zone depends on RBI-derived risk levels and the desired level of detection confidence and the anticipated damage morphology and distribution. So basically, for a non-intrusive inspection, we've got to consider the specific features of the equipment and where we anticipate that wall loss or cracking. Once identified, we need to make sure that the tool that we're using is going to be able to characterize and size that damage appropriately. RBI, with its inherent flexibility, can help realize the inspection interval and scope benefits of automated and better inspections that can answer these questions. What we're showing here is an example matrix. In this case, we're looking at an example of how you would look at the different levels of confidence for a general thinning strategy. To put together a proper non-intrusive inspection scope of work, there's going to be multiple tables like this and a great deal of supplemental information to make to keep the inspection appropriate to a specific asset and its needs. RBI requirements for inspection coverage like wall loss area, weld seam length depend on the level of confidence that the inspection will find the potential damage. For example, some of the challenges are any actual corrosion has varying depth across the surface, and any weld seam flaw could be distributed randomly along the seam. But by focusing on the likeliest damage zones, and the inspection confidence will be greatly increased. All right, the inspection toolbox. So there's many tools in the non-intrusive inspection toolbox, and we're going to go through each in turn. Some of these technologies are proprietary. Some of them may involve variations on technology you already have on your site. But we're really working to prioritize inspection methodologies that lend themselves well to easy access, simple logistics, the highest possible data density that we can achieve, and also a scalable digital output. While drones are routinely used for internal visual inspections of equipment, especially in the cage configuration seen in this picture, in the event of an internal 510 evaluation, for example, a drone could eliminate the need for a confined space entry and still meet the visual requirements of the inspection. In the case of a non-intrusive inspection, aerial footage could be used to acquire external visual data to assess coatings and external corrosion on the surface of the asset. I've seen cases, for example, where we are collecting images at the top of a column or a sphere where there's damaged ladders or unsafe access conditions that are going to limit the possibility of a human visual inspection. Now, the kinds of equipment we're inspecting with non-intrusive inspections, they don't exist in isolation. There's other tools such as digital radiography that can provide an excellent assessment of external components, such as nozzles, valves, and piping that connect the vessels and assets or the equipment we're looking at to the other equipment on the site. Again, we're looking at the digital outputs from this newer equipment. They make it really easy to store and access this data and lend themselves very well to combining all these methodologies together. All right, wall loss damage mechanisms. A long-time solution for quantifying wall loss was the use of ultrasonic A scans and measuring wall loss from the vessel's exterior. Operators normally have in-house capabilities for thickness gauging, and it can be inexpensive. But the challenge here is that the UT spot checks have negligible surface coverage and a very low probability of finding localized corrosion. As a result of all this and the limitations described above, UT spot checks and even UT grid scans may not capture the worst of the wall loss. They're not easily repeatable, and they're not statistically representative of actual wall loss. This is a prime example of where automating our tool set is going to pay off well. Automated ultrasonic testing is commonly deployed technology that can thoroughly quantify wall loss. With thousands of readings per square foot, it easily overcomes the limitations of UT spot checking and localization. Other solutions such as rapid ultrasonic gridding can offer a compromise or new compromises in data density and speed and access advantages. Like AUT, hundreds of XY coordinated readings per square foot are collected, but it is a faster process that often does not require the same access considerations and surface prep that some other methodologies may have. Now, rapid ultrasonic gridding is a proprietary technology of ours, and we do currently use it in a broad variety of applications, including highly relevant assets to this discussion, such as spheres, but also on boilers and above ground storage tanks as well. We're able to corrosion map millions of XY coordinated UT thickness readings in a short amount of time. We're able to use those data sets to build 2-dimensional and 3-dimensional models. So one of the newest technologies we're deploying and taking it a step further than AUT is our rapid AUT. Here you can see the two different methodologies racing side by side on a 2 foot by 5 foot area. It's being scanned. By adding extra elements of a phased array system, we're getting 5 times the speed and up to 10 times the data for the same amount of time or on the same inspection. Now, speed and shorter job scope are always going to be its own reward, but this extra data reduces the false callouts and lends itself to overall greater accuracy. Now, of note, all of our platforms that we employ here at Gecko are steerable, which allows for very flexible deployment and really simple access requirements in a lot of cases. Now, a case study here that where we were specifically answering the question of, are we still safe regarding our wall ash, or do we still have enough metal thickness to meet our requirements? This was an inspection where we inspected 4 spears over 50 foot in diameter. One, I believe, was just a little bit over 70 foot in diameter, but we collected a minimum of 4 million unique XY coordinated measurements on the entire scope of work. And we're able to do this for all 4 spheres in just 6 working shifts. So it's a very fast technology that gives you a really high level of data density. Obviously, that data can be extrapolated and used for models such as the one that you're seeing here. The second component of our inspection is going to be weld-related damage mechanisms. There's a couple of primary tools here, and they can actually both be used alone, or they can be used simultaneously on the same access equipment or on the same robotic platform. But time of flight diffraction, an extremely sensitive tool that's going to be able to detect cracking and flaws regardless of orientation. Supplementing this, we do have phased array, which does have its own advantages, especially around slag and hydrogen damage like HIC and SOHIC. Now, both of those methodologies mounted on the same carriage can be a single pass way to really take a deep look at a variety of weld-related damages. Now, here's an example, or this is a case study where we're looking at bullet tanks. This is going to be a case where we deployed 2 separate robots on the same asset. One, of course, is going to be our rapid ultrasonic gridding, where we scanned the shell. And the second one was going to be a crawler that was doing a time of flight inspection on all the weld seams. So the scope of work here, or the evaluation, or the RBI defined scope of work actually was 100% coverage with time of flight on the weld seams and 100% coverage of the shell, which we're able to do in just a little under 2 shifts. All right, so as you've seen in the visuals for the slides that we've already been looking at, the current state data is being captured by the robots isn't the only information relevant to an inspection. These interactive data sets lend themselves very well to positionally relevant links for supplemental materials. As we bring in more methodologies from more different sources, whether it's historical documents or say some drone footage perhaps, we can combine all these into one digital platform. A lot of companies are already doing this. They're already looking at the systems for the digitization, but most of them do not have a component for incorporating quantitative data into their modeling and into their systems. So we feel that by answering these needs today with what our clients require today to meet their compliance goals, we're also building the data sets that are going to be able to populate these systems and be the foundation for the additional data and the supplemental targeted information. What you see here is what we see when we're looking 5 and 10 years down the road. As clients are using more and more methodologies to map out and catalog their sites, we believe that eventually, probably in the nearer term, there's going to be a need to incorporate that qualitative data that I mentioned. Eventually you're going to need numbers, you're going to need thicknesses, And it's that quantitative data that's going to let you extrapolate the life cycle of the asset, anticipate that the eventual retirement date of the asset, and ultimately use fewer, better inspections to reduce the overall cost of maintenance of the asset through its life cycle. So the value of risk-based inspection planning is now widely recognized by the industry. Its value can be increased by using new proven NDE technology, which can provide quantitative information to the RBI program and be leveraged by reliability engineers for more accurate predictions, fact-based, not opinion-based. Area coverage non-intrusive inspections using advanced NDE techniques can close the confidence gaps associated with traditional inspections and provide a beneficial interaction of RBI and non-intrusive inspection activities. The risk-based umbrella, in a broader sense, also extends to pressure equipment design, earlier life cycle integrity assurances, and continuous integrity monitoring, all of which support RBI findings and further optimize inspection intervals. When these gears mesh together, a breakthrough of equipment integrity confidence can be achieved and associated failure risks can be mitigated to the lowest practical levels. To achieve this, the industry needs to take advantage of new inspection and monitoring practices, and fortunately, the elements exist to achieve this goal. Thank you, everyone, and welcome your questions at this time.
Great, thanks, Quinn. So we'll go ahead and start the Q&A. Everybody who's on the call now, if you have a question, feel free to use the Q&A feature at the bottom of your Zoom screen and we can get those answered for you. Just as a general question, Quinn, I know that with the RUG system itself, it has the capability of obviously pulling in pretty dense data into the portal that you were showing off. Can you talk a little bit more as far as the type of inspection that it's doing, a little bit more detail of the robot itself, and then maybe even a little insight as far as what people can expect if they were to get that type of inspection year over year?
Yeah, absolutely. So if we're looking at the spectrum of inspections, on one side, we've got our manual sampling inspections, and on the other end of the spectrum regarding speed and data density is going to be an AUT solution, which we also offer. So the advantage of RUG is taking slightly less data density using multiple transducers. And by doing so, it's able to travel faster and cover more square feet per minute. An example on the higher end, probably of our capabilities is going to be a 60 linear feet per minute. And we can collect up to 120 square feet per minute, depending on the robot and of course the operating conditions that we're working under. So this is going to be quite a bit faster than any of the AUT, even our rapid AUT solutions. So there's going to be some big advantages there. Also, the significant magnetic adhesion of our robot, as well as the powerful motors, will let us operate at high elevations. It'll let us climb to some pretty significant heights that most other platforms I'm aware of won't be able to achieve. They'll also be able to use onboard cameras to operate outside of the line of sight in a limited capacity. So there are some elements there that are going to not just speed up the inspection, but also reduce the need to block off critical paths with scaffolding, or to remove obstructions that could otherwise be maneuvered around by the robot. Now, once we have the data collection, or a typical result of this is going to be, as many as several million A-scan readings in a day across thousands, possibly even 10,000 square feet, again, depending on conditions. But it's going to be a high level of output, and it's going to be a really nice foundational data set that can scale into large projects or encompass large projects. And it's going to be able to be modeled or provide the foundational numbers for modeling in 2 dimensions and 3 dimensions.
Great. So as far as the data, somebody wants to know, what are the options as far as data export? And also some options for the data form for AUT or similar inspections?
Great question. So Excel spreadsheets are pretty much the industry standard right now, and it's something that we're going to be able to provide for any inspection, and pretty much regardless of the methodology that's being used. Where we're going to deviate from this is that we deliver what you saw, a lot of the 2-dimensional and 3-dimensional images that you saw. These are actually taken from our portal which is going to be an online digital tool to be able to collect or be able to review and manipulate the inspection data that we've collected. So once you get into your portal, there's a variety of ways to take a variety of pieces of information. We don't have a lock-in on the portal so that you can print out or save the Excel spreadsheets, for example, or if you like a three-dimensional image that we have included, you'll be able to download that and possibly even print it or use it in subsequent conversations, like making the case to executives that a piece of equipment needs substantial repairs or needs replacement at this time. So there's no lock-ins, but a variety of ways to be able to access that data.
Great. And what NDE would you recommend for corrosion under insulation and fireproofing inspection over long stretches of insulated piping? This person's looking for little to preferably no need to remove the insulation.
If I could figure out a way to inspect under insulation or through insulation, I'd be retiring very soon. But so we do have some of our tools lend themselves very well to specific corrosion under insulation challenges. Long insulated pipelines are not going to be one of those that lends itself well. An example of where we would be useful in a corrosion or in an insulation related corrosion situation would be, for example, an insulated tank or an insulated vessel where we are inspecting it internally and looking externally for exterior corrosion, for the earliest wall loss that would be related to a water leak through your insulation. So you don't have to scaffold inside of your storage tank, for example. You don't have to strip any insulation, but you're still getting a view of the entirety of your shell in a very short amount of time. Fireproofing is something that actually has been coming up quite a bit for us recently, as well as exterior insulation. Both of those, again, would have the same advantages or would appreciate the same advantages of an internal looking externally inspection.
Great. And so have you completed any scopes of work in Australia for boiler tube scanning? And then do you have any Australian companies that you're affiliated with?
So I would need to get back to you on that. Yes, long story short, yes, but right now, right off the top of my head, I cannot recall who we've been in discussions with or where we're at situationally down under.
Great. So we'll just give it a couple more minutes here in case there's other questions that want to come through from anybody that's sitting on the attendees. Just as a reminder, use the Q&A feature at the bottom of your screen there to send in questions. Otherwise, we'll just wait here.
Well, while we've got a moment here, I do want to emphasize that there are some specific examples where an intrusive inspection might actually be desired, might actually be necessary. Blistering on the internal diameter would be something that would be more appropriately caught with an internal visual inspection. But with all of the advantages of external inspections and with all the new tools and their ability to assess the damage from the outside, it's those reasons to enter are becoming increasingly fewer.
And then somebody wants to know if your services are offered in Canada.
We would be very happy to come to Canada. And we'd love to follow up with a little bit more of a Canadian specific discussion. This wasn't the same person that asked about insulation, is it?
No. So what temperatures, curious on what temperatures you've seen performing in-service scanning of pressure vessels?
So the rapid ultrasonic gridding is capable of going up to 300 degrees Fahrenheit or 120 degrees Celsius. As far as some of our other platforms, I believe we're going to be cooler. I think most of them are going to need to stay below about 150 degrees on the skin temp.
And then what's your process for inspecting tanks that hold hazardous chemicals or hazardous waste?
That's a broad question. So are we talking about the tank's been out of service and it's been cleaned out, or it's been?
No specifics here, so maybe
gotcha.
answer in both ways.
Gotcha. So the robots we have are not intrinsically safe. So let's start there in answering that question. So we will need a fresh air supplied and cleaned vessel to be inspected. If we can inspect externally, like what we've been talking about here, but we would of course want to get with the safety department and make sure that we are not intrinsically safe robots are going to be suitable for the application. Very situational. We appreciate the chance to chat about that a little bit more, but there's a lot of variables there. Thank you for the question.
All right. Well, I think that's it. Well, thank you, Quinn, for your presentation. This is really great.
Thank you
For
everyone for
anybody
attending.
that ends up having another question, after we've closed out the webinar, feel free to email us. And then otherwise, we will be sending the recording to everyone after we've finished.